Hello everyone, it's almost 1:30 a.m. and I gotta speak in a softer voice than I usually do because people are asleep. And in today's session, we're gonna be talking about how to configure Bgp Weight attributes. So Weight is a Cisco proprietary Bgp attribute that can be used to select a certain path. Here's what you need to know about Weight. Weight is the first Bgp attribute in the list. It is Cisco proprietary, so you won't find it on Juniper, Arista, and etc. Weight is not exchanged between Bgp routers. Weight is only local on the router. The path with the highest weight is preferred. Let me see if I can increase the gain on this just a tad bit. There we go. I think that would work better. Wait a second. Test. I think it's at max now, and I think I should be good. Alright, let me give you an example of Bgp weight. So it looks like we have S1, 2, 3, and 4, each with their own routers, and looks like R1 is multi-homing to R2 and R4. And on one path, it looks like R1 set a weight of 500 versus the other path, which has a weight of 400. So in this case, because the weight is greater here, it's gonna traverse this path. In the case where I suppose it has the same prefix from both R2 and R4. Alright, so R1 is an AS1, or R1 and AS1 can reach AS3 through AS2 or AS4. If you want to ensure AS2 is always used as the best path, you can change the weight. In my example, the weight for the path to AS2 is set to 500 and higher than the weight of 400 for AS4. Let's see what it looks like on real Cisco routers. This is the topology we'll use, and I already have it copied over here, so let's actually put in some nodes. Actually, let me just make the, how do I, there it is. Just do it like this. R1 will be here, R2 will be here, and we'll have R3, 0, 0, 0, 2. Oh, that's why, because the picture is in the foreground, but if I lower it, I don't want to see this message again. It should be good. Do I even have a, yeah I do, nice. This one is F10 to F10 as well. And up here we have F00 to F10. Alright, let's start up these nodes. And let's open up MOBA Xterm. And what is this? I don't want to buy it. I don't want to buy it. Alright, let's close these consoles out. Alright, now we'll press console connect to all nodes. Alright, we're at R1, and the first thing I do is I configure all the interfaces. So config t, interface fa00. We're going to give it an IP address of 192.168.12.1 with a subnet mask of /24. And no shut it. And FA10. Given an IP address of 192.168.13.1. Same size subnet mask. No shut that. It does not look like R1 has any loopback interfaces to configure. So last thing that we need to configure here is the Bgp configurations. So router Bgp with autonomous system number 1, neighbor up with, it says right here, we're not going to be neighbors with the loopback addresses. We're going to be neighbors with the connected interfaces that are connecting R1 and R2, and also R1 and R3. So in that case, we're going to use these two IP addresses. One here and one here. 192.168. What is it going to be? 12.2 with remote autonomous system number 2. And same thing except with a different IP address. 3, right? I think that's right. Okay, and I do write memory. Over at R2, we're going to do the same thing. We're going to configure some interfaces. Int fa00. Oh, sorry, I'm looking at R1. Interface. So the first one we'll do is fa20. Give it an IP address of 192.168.12.2 with the subnet mask of /24. And I'll no shut it to turn it on. And then I'll move on to the next interface. Interface fa10, which is connecting to R3. We'll give this interface an IP address of 192.168.23.2. Give it a subnet mask of /24 as well. And we have a loopback interface that is configured with IP address 192.2.2.2 with /24. And no need to shut down, or no shut here, because loopback interfaces are always enabled by default. Let's see. Okay, so router configurations. Router Bgp with autonomous system number 2. And let's actually scroll down and see what R2 wants me to put down. So we have neighbor 192.168.12.1 for router 1, remote AS1, neighbor 192.168.13.3. Oh, I'm sorry, it's going to be 23. Yeah, .3. The remote autonomous system number 2, as it will be a iBGP connection. And we're also going to add this. We're also going to add this network statement where we'll advertise out the loopback address, and we'll give it a mask of /24. All right, I think we're done here. Do write mem. All right, so we're at R3 right now. Our final router to configure. Configure terminal. Interface interface FA00. Give that an IP address of 192.168.23.3/24. No shut interface FA10 with an IP address of 192.168.13.3/24. No shut that, and it looks like we have a loopback address to configure as well. So interface LO0, IP address 2.2.3. Why did it use the same loopback address? No, it would be different. It's still, that would work actually. Yeah, that would be fine. Anyway, /24. Okay, and what are we doing now? We're configuring router BGP, autonomous system number 2. What neighbors are we going to configure? Alright, we're going to configure our neighbor 192.168.13.1 to connect with router 1. We're also going to connect via BGP with 192.168.23.2, remote 8S2, and we're going to advertise out the 2.2.0/24 network. Do right map. Do show IP BGP summary. Let's see, so it's currently in active state, but I don't think there should be any problems. So that it should establish, but why is it still inactive? In that case, let's try to do this. Debug IP BGP. What is it gonna say? And I'm gonna do that too for R2. IP debug, debug IP BGP. What's going on here? Alright, so R3 is inactive, and then it tries to send an open message. Is that why it goes back? Connection timeout. Remote host not responding. Open active. Delayed. Why is it not responding? Show IP route. 192.168.23. How that connected, right? Show IP route. Alright, the reason why it doesn't work is because for R2 I forgot to configure the FA1/0 interface with an IP address for some reason. So let me fix that. Let me double check if that's actually the case. Show run interface FA10. No, oh, that's why. It's because the interface is shut down. I forgot to no shut it. Oh crap, I have a viewer. Hey Natzak, what's going on? Alright, interface FA10, and I'm gonna no shut this, and the BGP neighborhood relationship should get established now, which we do see in the logs right here. Okay. Above, you'll find the configurations for BGP. Now let's take a detailed look at R1. Alright, moving to R1. Do a show IP BGP. We see that the 2.2.2/24 network is preferring the path to R2. And why is that? Let's see what his explanation is. So R1 decided to use 192.168.12.2 as an X hub. All of the BGP attributes are the same, so it comes down to the router ID to select the winner. And in this case, the lower router IP wins in this race. Is that how it was? I'm actually gonna go back and double check. Okay, so yeah, prefer the path with the lowest neighbor IP address. Cool. I confirmed that. Alright, what's going on? Alright, looks like what he's going to do is he's going to configure a neighbor with a weight of 500. So I'll do that too. Router BGP 1 neighbor 192.168.13.3, which is R3, with a weight of 500. You can configure weight per neighbor using the weight command. All prefixes from this neighbor will have a weight of 500. And oh, he's clearing his BGP, but do I need to do that? Let's find out. Show IP BGP. Let's see. It looks like, according to this right here, the greater than symbol, it's still preferring the same path, which is to R2. And what we want when we configured the weight is we wanted R3 to be the preferred path. So it didn't take in effect yet, and that's probably because we need to issue this this command. So let's do that. Actually, let's do this one more time. Yep. Okay. Anyway, clear IP BGP. What does star do? Actually, I don't even know. Oh, star is clear all peers. Trying to figure out where the option is to give me a sound notification, but then I realized that my sound isn't going through my speakers right now. It's going to go through my headphones, and there was probably sound that notified me that someone said something in chat. So let me put these on. All right. Sometimes BGP behaves like an oil tanker, so let's, okay, I read that. And it looks like in the log messages, the neighborhood adjacencies have reset. And if I do a show IP BGP again, then the new preferred path we see is that it is going through router 3 instead of router 2. And the path, or I'm sorry, the weight value is updated here, while before it remained the same. Cool. Now you can see that 192.168.13.3 has been selected as the next hop because the weight is now 500. What if we want to set the weight to 500 for just a couple of prefixes in AS2? Just creating another loopback interface. And another one here. Okay, what happens in a situation where you have the same addresses? All right, let's find out. Let us find out. Configure T, interface loopback 1, IP address 22.22.22.22. 255, 255, and 0. Router Bgp 2. Advertise this network out. Oops, we're going to do right mem. All right, do the same with router 3. Interface loopback 1. IP address 22.22.22.22 with a /24. Router Bgp 2. Advertise out. Awesome. So if we go back to router 1, we see that this new /24 prefix is being shared by both routers 2 and routers 3, although the preferred path is router 3 because it has a weight attribute of 500. Yep. As you can see above, router 1 will use 192.168.13.3. What if I want to change the weight for just one prefix? Route maps to the rescue. Alright, so in R1, we're going to remove the weight statement. No neighbor to 192.168.13.3, which is router 3. And we're going to configure a route map. So route map, set weight as the names, permit 10, let's match IP address of 1, set weight to 400. Exit. Route map. Set. Oh, wait. Am I doing it right? Wait, why is he resetting the weight? 20. So the next item in the sequence, set weight 0, exit. This one permit 22, 22, 22. Oh, I see. I didn't understand it until he created the access list. All right. So if you match this network right here, set weight to 400, else the weight is 0. Okay, back to R1. Router BGP 1, egress 192.168.13.3, the route map of set weight, and that's ingress. And we'll reset our BGP again. BGP. So what do we have? Show BGP or show IP BGP. Now we only see entries from router 2, but not router 3. Why is that? Why is that? Oh, I know why. It's because I spelled set weight wrong. And I think by default it's it might use or it might initiate a new route map that it uses temporarily, or it might even create something called set right. And it's an implied deny since there's no statements in there yet. So that's what I'm going to assume that just happened. Okay. Router BGP 1. Actually, I should do a no on this statement right here. Router BGP 1. And do no. Set weight. Alright, so show IP BGP. Oh, wait, show IP route BGP. Okay. Wait, show IP BGP. Okay, there we go. That kind of sucks because I had to reset BGP. Like, I wonder if this is the same case if we were using real equipment. So right now I'm using GNS3, which is all emulation. But if it's live, then I don't think a safe route, a safe decision would be to clear IP, BGP, everything. I don't think you would want to do that in a production network. So I'm curious as to how, if you ran into a situation like this, what's the safe way to actually remediate something like this? Hopefully I'll figure that out. Anyway, it looks like we got the results that we were expecting. So for this network that's in a route map, what does it say again? If it matches what's in access list 1, then we'll set weight to 400. But if it doesn't set weight to 0, which we do see, where is it? Right here. So the weight is 0 here because it didn't match there. And these are both coming from router 3. So, and we only set it so router 3 is using that route map, so R2 is not going to get the same treatment. Sweet, I think we're done with this lesson. Alright, thanks for watching. I will start up another session or another stream for the next topic, which looks like it's going to be BGP local preference. Thanks for watching.